Hello guys, welcome back to Maison African Motives. Still working on mathematics N1. We are going to be revising the question paper which was written in April 2023. So this is April 2023 exams. We are given 3 hours for that, 9 to 12, and the requirements. We've got the graph paper, which means in this paper, we shall have a part that you're going to apply a graph paper. Okay, so you've got the instructions on the first part that you're supposed to understand on. Make sure that your answers, there are 3 to 3 decimal places, which is the most important part, and also to show all the proper working on your calculations. All right, so without wasting much time, let us quickly rush through the questions that we are given. In this case, we have got first part of the question. Question number 1, where we are given to simplify each of the following without a calculator by using exponential laws. So we are required in this case to apply or to use exponential laws in order for you to simplify. Okay, so the first part is on 1.1, where we are given the square root of x squared y to the exponent of 14. So remember from your laws of exponents, the square root simply means to the exponent of a half. If you are given x to the exponent of a half, it simply means the square root of x. So this part here simply means we have got x squared y to the exponent of 14 and everything to the exponent of a half. So that is what we are given in this case. Remember, from your laws of exponents, you can multiply an exponent and an exponent. So meaning to say here, we are going to multiply x to the exponent of 2 times a half. Y to the exponent of 14 also is going to be multiplied by a half. So this is going to give us x to the exponent 2 times a half, which is a 1. So this is x to the exponent of a 1. 14 times a half, which is a 7. So everything is going to be xy to the exponent of 7 in this case. So this one is just the same as just x. You can just write as x. All right, so this is how we can apply such typical questions. All right, we move on to the other part of the question, which is on 1.12, where we are given, again, to simplify using the same exponential laws. Okay, so if you have to check, here we are simply multiplying the bases which are the same. So remember, from our laws, if you're multiplying the bases which are the same, you are going to add the exponents. That's a plus b. So here we are simply going to add. So 1.12. So this is simply going to give us, here is same as to the exponent of a 1. So what we are simply going to do is to add the exponents. 1 is going to be added to 2. So that's going to be x to the exponent of 1 plus 2. The same thing in the denominator. We are going to add these exponents together. So that's x to the exponent of -1 plus a -2 plus a 0, but adding a 0 does not even affect. All right, so that's what you're going to have in this case. All right, so all from the top, which is the numerator, if you add 1 plus 2, that was going to give us x to the exponent of 3. All right, so everything in the denominator, this part, if you add -1 plus a -2, it simply means -1, -2, which is going to give us x to the exponent of -3, because here plus a 0 does not affect. So now we are left with a part of division. So remember that if you are dividing the bases which are the same, you subtract the exponents. So this is going to be x to the exponent of 3 minus -3. So we subtract the exponents in this case. So a negative and a negative, that's a positive. So that was going to give us x to the exponent of 3 plus 3, which is 6 in this case. All right, so this is what we're going to remain with at the end. All right, let's check the other part of the question, which was on 1.2, to simplify without a calculator again, but this time by using logarithmic laws. So this time we are supposed to use or to apply the laws of logarithm to simplify this whole part, and we've got 5 marks for that. Okay, so that's question 1.2. Let us have this one aside here. So we are given the logarithm. It was the square root of 16. That was the square root of 16 in the base of 4 minus the logarithm of 1 over 81, which is in the base of 3, minus the logarithm of 0, 0.125 in the base of 2. All right, so this is what we were given in this case. All right, this is the whole simplification. The log square root of 16 minus log 1 over 81 base 3 minus the logarithm of 0,125 in base of 2. And that was 5 marks. Okay, so if you are given to simplify such type of equation, we are supposed to use the laws or to apply with the laws of logarithms in this case. All right, so we simply, this part, guys, square root of 16, that's a 4. Remember, a number that multiplies itself to give us 16, that's a 4. So this we can rewrite as the logarithm of 4 in the base of 4. But here we've got a fraction 1 over 81. So whenever you are working with logarithms, also take or get rid that you are going to apply also some of the laws from your exponents. Laws. So like this part here, we are supposed to apply our exponents in this case. Remember, 1 over x is simply the same as x to the exponent of -1. So whenever you're given 1 over, that's a number to the exponent of -1. So this 1 over 81 is same as 1 over 81 is same as 81 to the exponent of -1. But we can actually write this in the base of 3. So we can try to reduce this 81 to the base of 3 because we've got a 3 here. Why are we actually wanting to write this in the base of 3? Because there is a law that we know that the logarithm of a in the base of a is equal to 1. That is, when a number and a base are the same on the logarithm, we are going to obtain it. So we are trying by all means to have such presentation like this, log 4 base 4. So meaning to say, let's try to write our 81 in terms of 3. So to write our 81 in terms of 3, that's 3 to the exponent of 4. But remember, there is a -1 which is there. So we're going to multiply by a negative. So this is going to be 3 to the exponent of -4. So meaning to say, on this part that we have, we are going to have negative the logarithm of 3 to the exponent of 4 in place of 1 over 81. That's now 3 to the exponent of -4 in the base of 3. Minus the same thing on 0,125. We express this part as a fraction. That's 0,125. If you express this as a fraction, we are going to obtain 1 over 8. That's simply 1 over 8. So 1 over 8, just like 1 over 81, it means 8 to the exponent of -1. So we can write our 8 here in the same manner as the base, which is 2. So 8 is same as 2 to the exponent of 3. But there is a negative that is there, so you're going to multiply with a negative. So that's 2 to the exponent of -3 is the same as 0,125. So in place of 0,125, we are going to write this as the logarithm of 2 to the exponent of -3 that is in base of 2. All right, so at this stage, what can we do? We have the idea of the logarithm of a number the same as the base here. We have it like in this case, we have got this part, we've got this part, but we are still affected by these exponents, -4 and -3. So how can we get rid of these exponents? How can we remove these exponents? Remember that if you are given any logarithm of m, this is same as the logarithm of m to the exponent of n in any base that you might be given. So meaning to say, if a number is multiplying a log, it can be raised to be an exponent of that log. So meaning to say, we can even reverse from when it is given as an exponent to multiply a logarithm. So it's going to be any log. So meaning to say, these numbers can be removed by multiplying the logarithm from this law that we are having here. So meaning to say, we are going to multiply here the logarithm of 4 in base of 4. We multiply -4 times negative. That's the same as -1. So it's -1 and -4, which is going to give us a positive. So that's 4 logarithm of 3 in base of 3. We do the same here, a -3, which is a -1 and a -3. So -1 times -3, which is going to give us a +3 logarithm of 2 in base of 2. So we have managed to rewrite this in the manner that we were looking for before, to say that the logarithm of a number in base of that same number gives us a 1. So meaning to say, wherever we've got this condition, we are going to replace with a 1, not the logarithm of a 1, but a direct numerical value, which is a 1. So in place of the logarithm of 4 base 4, we are going to replace with a 1. The logarithm of 3 in base of 3, that's a 1. The logarithm of 2 in base of 2, that's a 1. So meaning to say this can be, we can rewrite this as this part we got a 1 plus, that's 4 times 1. So this is going to be 4 times 1 plus 3 times a 1. So that's what you're going to have in this case. So if we add everything, in this case, that's 1 plus 4 plus 3, which is going to give us 8. So there is no log. There is no log on our final answer. It's just a normal number, a numerical value, which is what? Which is 8 in this case. Okay, so that is how we can use our logarithms together with the exponents to simplify questions. So when you're given questions on logarithms, like I said, don't expect to work everything under logarithm. Some of the things you need also to apply from your exponential laws and so forth. Okay, so this is what that was our question. Let's check the other part of the question, which is on 1.3, where now we are given this time to write the following in exponential form, this equation, which is in log form, in exponential form. All right, what you need to know or what you need to understand is that we can only rewrite a log to an exponential form when it is a single logarithm. So it follows that the logarithm of a, which is in base of b, when it is equal to c, this is a log form that we see here. So here we have got a log form, which is a single log in this case. So when you've got a single log like this, you can convert this to exponential form from this part a is equal to the b to the exponent of c. So we can write this now in exponential form. So this is what we are referring to as our exponential form. So meaning to say we can only rewrite in exponential form when we are given a single log. So it's a conversion from a single log to exponential form, which can be a vice versa from exponential form to log form. So meaning on this part, we are supposed to rewrite this as a single log. Remember from the law that we talked about, if a number is multiplying a log, we are going to raise this to be the exponent. Okay, what was, okay, I removed the previous part. Okay, but I think we still remember this law that I talked about, that this is going to be raised to be the exponent. So meaning to say we were going to obtain something like this. From this part, we are going to have the logarithm of x squared. So this 2 is raised to the exponent. So that's x squared in the base of y, which is equal to 3. So if we can write this, this is now a single log, like log a base b is equal to c. So that's log x squared. So this x squared, this part of x squared is the one that represents our a. So if we said a is now equal to b to the exponent of c, meaning to say we are going to say this a, which is our x squared, is equal to the b to the exponent of c. B represents the base. This is our b, and our b is represented by y this time. So this is y to the exponent of c, which is the answer to the logarithm, and our answer, which is this part, is 3. So that means x squared is equal to y to the exponent of 3. So that's an equation which is now in exponential form. So this is the one that we are asked to write as. All right, so that's how we can have this typical question. We move on to question 1.4, which is having 3 marks, which marks the last question on question number 1, where we are given to solve the variable without a calculator and show all working. All right, so we are given in this case the logarithm of 64 in base of x, which is equal to 2. So how can we calculate for x? Okay, so from that condition that we talked about, that we can convert a logarithm, a single log, to exponential form. This is the one that we applied here, that a is equal to b to the exponent of c. So if you have to check here, our base, our a is this number 64. So that means 64 is equal to the base, which is x to the exponent of 2. So we can rewrite this in the format that we are used to, which is the exponential form. So from this part, how can we solve for x? As we can see, having a squared here, to remove a square, we can simply introduce a square root or we can raise to the exponent of a half, which is the inverse of a 2 here. So the inverse of a 2, that's a half. We raise this to the exponent of a half, which simply means the square root of 64. So here we are going to have the square root of 64, which is equal to x. 2 times a half, that's x to the exponent of a 1. So x is going to be the square root of 64, which is plus or minus 8. But we know that we are dealing with x, which is a base. So this base cannot be a negative. So therefore, our x is going to be 8. We are going to have our x as a positive value, which is going to be 8. All right, so that was our question 1, having a total of 15 marks in this case. We move on to the question 2, which is, in this case, we were given to divide this expression by x minus y. So we are asked in this case to divide this expression by x minus y. Okay, if we had to check, this was actually a very, 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 very tricky question. Most of us would think to say, we are supposed to use long division, which is something that was going to be a disaster if we were to try that one. Okay, let me have this question aside because this was a very, very tricky part. Okay, so we are going to divide this whole part that we have here. It's unfortunate that I can't just copy this direct here. I can't just remove this part. Okay, so anyways, what I'm going to do is to rewrite this part and divide by x minus y. I'm going to show you what exactly we are supposed to have in this case. All right, so this is 2.1. We're given to divide minus 4x. Okay, is it minus 4x? All right, minus 4x squared exactly. Okay, just I'm getting old now. Okay, plus x cubed minus y cubed plus 4x y squared, like this. Okay, so this is the expression that you're given. Then we are asked to divide by x minus y, and that was 7 marks. Okay, so we are supposed to divide this by x minus y. So we are supposed to divide by x minus y. Okay. So here we are going to ask ourselves to say, can we apply the long division? This was going to be a little bit difficult for us. So here, this person, what they actually wanted you to do was to factor out and divide later on. Okay, let me explain it this way. If you have got numbers, let's get back to our normal numbers. If you are asked to divide 6 divide by 2 like this, okay, and it's difficult for you like to apply long division, maybe you are having a challenge on that, it simply means if you can rewrite this 6 as a product of its prime factors, like we know that 6 is 2 times 3. 2 times 3 is same as 6. So if we can multiply, if we can expand this 6 as 2 times 3, we can simply divide again by this 2. So now we can say 2 into 2, well, what we can properly see, 2 and 2 can cancel, meaning to say we remain with the 3. So this was the idea that we're supposed to have to factorize or to expand this 6 like what I did 2 times 3. When you are dealing in terms of algebra is to factorize or to expand. So you're supposed to factorize this part that you are given from this expression, this part. We are supposed to factorize this. So how are we going to factorize this expression? So that once we factorize like 2 times 3, we can simply divide by x minus 1. Okay, if you are to check here, there is a cubic expression that is in the middle term. Let me take it this way. There is a cubic part that we have here, x cubed minus y cubed. This can be factorized, this part. This part can be factorized. We know the identity for this, so we can separate this. So meaning to say, I'm going to separate this part and the last part, all right? So here, just be patient, guys. So minus 4x squared plus 4xy squared. I've taken the first part and the last part. So this is the first part, okay? There's a y here, there's a y there. So this is our first part, this is the last part. But everything is supposed to be added to this part that I said, the cubic part of x cubed minus y cubed. So I'm going to add this at the end. Plus x cubed minus y cubed like this. Okay. There's something that is going to happen there. If you check here, we are having an expression that has got 4 terms. We've got 4 terms. 1, 2, 3, 4. So what you can do is to factorize for the first 2 terms here. What is common for these 2 terms? But what you are going to do before you factorize for these 2 terms, consider what you have for the remaining 2 terms, these 2 terms here, which is x cubed minus y cubed. Remember, from our factorization, x cubed minus y cubed is same as x minus y into x squared plus xy plus y squared. Where is this one taken from? This is taken from the identity a cubed minus b cubed, which is equal to a minus b into a squared plus ab plus b squared. This is your factorization of a cubic expression of this nature. If it is a cubed plus b cubed like this, this is equal to a plus b into a squared minus ab plus b squared. We are also having this. I think we still remember this part. So this is what we are obtaining from this x cubed minus y cubed. So we are considering to say when we factorize for these 2 terms that we have, we must also consider to say we must obtain x minus y from these 2. So what is it that we can factor out so that we obtain a positive x and a negative y? If you check here, we can factor out a negative 4 so that this x can be a positive. So we factor out negative 4xy like this. The moment we factor out negative, okay, the moment we factor out a negative 4xy here, it means this is going to be positive. Negative divided by negative, that's a positive. 4 and 4 cancels. X squared divided by x, that is x. Y and y here, these 2 cancels. We move on to this part. It's now 4 divided by a negative 4. So it is going to be a negative. The x here and the x, they cancel. We move on to y squared divided by this y. So this is going to be y like this. So this is what we are obtaining from these 2 terms, but being added to this last part that we got here. So remember we said, okay, let me just try to reshift this part here. All right, let's just hope it is going to work. All right, so let me, okay, now it's choosing what to pick here. All right, no problem for that one. I just wanted to shift this whole part up. All right, so this is what we are going to obtain from these 2 expressions. These 2 that we have, it's a cubic expression. I want you to understand this type of equation, guys. This is a cubic expression that you applied this identity of factor from your factorization concept. But if you check properly, the reason why I was saying you must make sure that these 2 are the same, the x minus y, the x minus y. Remember, it is the one that we are supposed to use to divide. We are supposed to divide by x minus y. So now if you check here, we have got x minus y and we've got x minus y, which is common. So we are going to further again factorize. So this time we are going to factor out x minus y, which is common. So as you can see here, x minus y is common. So we are going to factor out the x minus y. So to factor out x minus y like this, meaning to say we are going to remain, if we remove x minus y here, we remain with minus 4xy. So we are going to remain with minus 4xy like this. Okay, we move on to this part. If we factor out x minus y, if we divide x minus y and x minus y, meaning to say we are going to remain with this expression. This is the one that we are going to remain with. So we are going to remain with plus x squared plus xy plus y cubed. That's y squared, sorry. This one is y squared like this. So this is what we are going to remain with at the end. All right. So now we can simplify further. Before we divide, let us just simplify our expression further. So that's x minus y into collect like terms. So you can just start here with x squared. So this is going to be x squared. We collect like terms here, minus 4xy and xy. This is same as 1xy. So that's minus 4 plus 1. So minus 4 plus 1, that's minus 3. So you're going to obtain minus 3xy plus y squared, like this. All right, so this is what we are obtaining from factorizing this cubic expression that we had before. Remember, we had this cubic, there was this type of expression that we had. After factorizing this, we are obtaining this expression. Now remember what I was saying. From the 6 divided by 2, we said if we can expand to 2 times 3, we can simply divide properly. This is what we did. We expanded our expression, or you factorize into brackets. Now we can simply divide to say this whole expression that is representing our question, we are going to have it as x minus y into this expression as it is. So this is into x squared minus 3xy plus y squared, like this, divided 2. We are now dividing with the part that we are asked divide by x minus y. So if we divide this whole expression by x minus y like this, I want you to see what's going to happen. The x minus y and the x minus y are the same. So this can cancel. So therefore, our answer is going to remain as this part that is remaining in the bracket, x squared minus 3xy plus y squared. So this is what we are going to remain with on your final answer. All right. So this was a very, very tricky question. Very, very tricky question. I understand, guys, but let's just hope from these explanations we understand something. We are going to work with such typical questions. There are actually many questions like this. So I'm going to bring out other questions so that we understand much. This is just a revision of a question paper, but we shall have this as a topic. This can actually help a lot. All right, let's check what we got on the question 2.2, where we are given now to remove the brackets. All right, so here I just want to change this part. We are asked on 2.2, remove the brackets and simplify. So here we have got 2 brackets, the outer bracket and the inner bracket. So what you can simply do is to remove from the inner bracket. Okay, so let me just try to extend a little bit here. So what you can do is to simply expand the inner bracket first. So that is going to be 2.2. So you're going to remain with the 4 into, we start with the inner bracket. So the inner bracket is this one that is affected by minus x. So we are going to have x squared. Then we multiply negative x times 2x. This is going to be negative 2x squared. Negative x is going to multiply again in this bracket, which is negative x. So it's negative, negative, which is a positive. So that's positive 3x, like this. So we start by the inner bracket, then we move to the outer bracket. So before you move to the outer bracket, yes, you can simplify by collecting like terms in the inner bracket. In this case, we can collect like terms. Here we've got x squared minus 2x squared, which is same as 1. So this is same as 1 minus 2. So 1 minus 2, that's minus 1, which is minus 1x squared, or minus x squared plus 3x, like this. So here now we can multiply by the 4. 4 times negative 1x. This is going to be a negative 4. So we've got negative 4x squared. 4 times 3. So the 4 also is going to multiply with the 3x. So that's 4 times 3, which is 12. So you're going to obtain 12x in this case. Okay, so our answer is going to be negative 4x squared plus negative 4x squared plus 12x in this case. All right, so that was 4 marks just to remove brackets and to simplify. All right, on question 3, we are now given to factorize fully the following expressions. All right, factorize. Okay, let's check what we got in this case. The first part, it was just a direct question. If you could just properly see what's here, we will see that there is 1 over 4. There is 4 here, there is 4 here, there is 4. Between these, the highest common factor is 1 over 4. Remember? as the smallest number that we can have, the highest number that we can have as a factor. So that's 1/4 can be divided into n of these. So this is going to be 1/4. So you can actually factor out 1/4. Let me just start by answering here. We can factor out 1/4. We move on to the x and y. Is x common? There is x squared, there is x, there is x. So x is common. But which one is the highest common factor? Remember, the highest common factor is the one that has got the smallest exponent, or the least exponent, which is x. So you can take this x or you can take this x. So you're just going to write it as x, the one that has got the smallest exponent. Y is not common. We do not have the y value. We have got here, we've got here, but on this part, we do not have the y value, meaning to say y is not common. So y cannot be our factor, because a factor is supposed to be common throughout. So this is the highest common factor that we have. So once you have got your highest common factor, then you divide. So that's 1/4, divide by 1/4. That's simply a 1. X squared, divide by x. This is going to be x. Remember, there are two of them. So you divide by 1, we're going to remain with 1. So this simply, this part here simply means you are dividing this. You are saying 2/4 divide by, so you can simply use your calculator. 2/4 divided to 1/4, like this. This is 2/4 divided by 1/4. You are going to obtain 2 in this case. So this is going to be a plus 2. So equal to plus 2. All right, we move on to x. X and x will cancel, meaning to say we remain with a y. So this is going to be 2y. The same thing on the minus 3/4. You do the same thing. Minus 3/4 on this part, divide by 1/4, your factor. So you divide by 1/4. This is going to give us -3. So that's -3. X and x will cancel, meaning to say we remain with y squared, like this. All right, so this is what you're going to have at the end. And if you check here, we do not have anything that is common. So we have managed to factorize. We are done. There's nothing that we can do. All right, question 3.12. Again, it is on factorization, but what type of expression do we have in this case? If you have to check here, this is a part of 4 terms, just like what we saw in the previous part, where we are given 4 terms. That's 1, 2, 3, 4. So on a condition like this, we can group our terms into 2. So that is, if we are to group our terms into 2, we can factor out what is common in this case. So here 2 is common, so we can factor out 2. If we factor out 2, we remain with a minus b. That's 2a divided by 2, we remain with a, minus 2b divided by 2, we remain with a -b, as 2 and 2 will cancel. The same thing that you have done is supposed to be happen here in this part. We are supposed to do the same thing from this part. We are supposed to factor out what is common, but maintaining the same bracket of a minus b. So meaning to say, whatever that you're going to factor out, you must consider what is going to happen with a. A is going to be a positive, because here it's a positive. So what are we going to factor out so that a is going to be a positive? We are going to factor out a negative so that this can be a positive. And x is common, so that will be minus x. So if you factor out minus x, that means a negative and a negative will cancel. X and x will cancel. We remain with a positive a. We move on to this part, plus and a minus. That's a minus. Okay, x and x will cancel, meaning to say we remain with b if we divide. All right, so as you can see, the two brackets are the same. We've got a minus b, a minus b. This is the major part that we are looking for. Once these two are common, then we can factor out the a minus b. If we factor out the a minus b, on this part, we remain with 2. That's, we divide a minus b will cancel. We remain with a 2. On this part, we remain with a minus x. So this is what you're going to have at the end. All right, so that was our factorization on question 3.12. Okay, we move on to the other part, which is 3.2. 3.2. This is 3.12 and this is 3.2, where we are given to simplify the following. Okay, so this is an expression where we are given to divide the following fractions, and we've got 5 marks for that. Okay, so what can we do in this case? Okay, first, yes, we know that we are dividing in this case. We can start by introducing the multiplication so that we do not confuse ourselves, or we can start by factorization, because this was somehow a direct type of a factorization. If you check from the numerator of the first part here, 3 is just common, so you can factor out 3. We remain 3x and 3. We remain with x. 3 and 3 cancels, we remain with y. On 3z, 3 and 3 cancels, we remain with a positive z. Everything over 6 here is common, so you can factor out 6. We remain with x, here we remain with y. So this is going to be x minus y if we factor out 6. Divided 2, we are still dividing. So on the other part, let's check, do we have anything that is common? Yes, 2 here is common throughout, so you can factor out 2. That is 2 and 2, we remain with x. 2y and 2, we remain with positive y, positive z, like that. Okay, then we check in the denominator here, 8 is also common, so you've got 8, but also take note, x is also common. There you have got x squared, here we've got x. So the one that has got the smallest power is x, so that's our highest common factor. So if you factor out 8x, that's 8x squared divided by 8x, we remain with x minus 8, and this 8 gives us a negative, because this is a positive, so you get a negative. So 8 and 8 cancels, x and x also cancels, we remain with a y. So this is going to be minus y. Okay, so at this stage, yes, you can divide like where you can, like if it is from a single fraction, but to avoid such mistakes, just introduce your multiplication, then everything is going to be perfect. So the first part, this was 3 into x plus y plus z, everything into 6, that's 6 into x minus y times. Remember that the moment you introduce a multiplication, you are now inverting this fraction. You interchange what is in the denominator, you write it in the numerator. From the numerator, you write it in the denominator. So this is going to give us 8x is now on top. So that's 8x into x minus y, everything over 2 into x plus y plus z. So that's it, guys. At this stage, we can cancel as long it is from the numerator to the denominator, whether it's from the first fraction or it's from the first fraction and the second fraction, as long it is from the numerator and the denominator. What I'm simply saying is such as x plus y plus z, x plus y plus z. We can cancel because this is in the numerator, this is in the denominator. Also, we've got x minus y, we've got x minus y here. All right, we move on to the numbers. That's 3 into 3, that is 1. 3 into 6, that is a 2. We move on here, 2 into 2, that is 1. 2 into 8, that is a 4. We've got a 2 here, 2 into 2, that is 1. 2 into 4, we remain with a 2. So here we are going to remain with a 2, and this x, the x, remember, is not affected. So these 2 here and this x are not affected. So meaning to say our answer from the numerator, we are going to remain with 2x in this case. All right, so from the numerator, we are going to remain with 2x over 1. So from the denominator, we are just left with 1. So 2x over 1 simply means 2x. Okay, so this is how we can actually apply our simplification from factorizing. Then we can cancel whatever that we can as long it is from the numerator to the denominator of the other fraction. Okay, so that was our question 3.2. Let's check what we have on the other part. So on the other part here, we've got question 3.3, which was for us to determine the following, okay, from algebraic terms that we have, the prime factors of each term. Okay, so you need the prime factors. So prime factors are only obtained from numbers. So if we are saying prime factors, we say 12 here. What are the prime factors of 12? We express 12 as a product of its prime factors. Remember, the smallest number is 2. 12 divided by 2, that is 6. We move on to 2 again. 6 divided by 2, that is 3. We move on to 3. 3 divided by 3, that is 1. So meaning to say 12 can be written as 2 times 2 times 2. So that's 2 times 2 times 2, which can, okay, times 3, sorry, that's 3 here, which can also be written as 2 times 2 is same as 2 squared times 3. So we can write our 12 as 2 squared times 3, just in the same way as a cubed, b cubed this way. Okay, so this is what we asked in this case. We do the same thing on 81. We start, the smallest number is 3. 81 divided by 3, that is 27. Divided by 3, that is 9. Divide by 3, that is 3. 3 divided by 3, that is 1. So meaning to say 81 can be written as 3 times 3 times 3 times 3. So that's 3 times 3 times 3 times 3, which is the same as 3 to the exponent of 4. So this is what we can simply write in place of what? In place of 81. Okay, so if we've got this, we are done. The first question is just to write this as product of prime factors of each term. Okay, then on the other part of the question now, on 3.32, we are asked now to calculate or to determine the lowest common multiple, which is the LCM. So the LCM, remember guys what I said, you take the highest powers, terms that has got highest powers, and the LCM, as long a term appears, that term must be written. Every term must be on your answer. Okay, so let's start with 12 on the numbers. We have got the 2 to the exponent of 2 here. Here we do not have 2, so we are going to take this one. As long a number appears, it must be written on the LCM. So we've got 2 to the exponent of 2. We move on to 3. We have got 3 here, we have got 3 here, but which one has got the highest power? Because LCM, it's all about the one that has got the highest power. So that is the 3 to the exponent of 4. So this is going to be times 3 to the exponent of 4. Then we move on to the part that we are given. In this case, the 12, we have got the letters here. So here we are supposed to have a cubed b c. Okay, so this is a b squared c. Okay, so if you check on 12 here, with this a, on 81 there is a, but which one has got the highest exponent? That's a to the exponent of 3. So that's the LCM. We move on to b. There is b, there is b. The one that has got the highest power, that is b to the exponent of 2. C is the same. Here is just C. This is just this. So we just take as it is. All right. So this is your LCM. So if you multiply these two, 2 to the exponent of 2 times 3 to the exponent of 4, this is going to give us 324. That's a to the exponent of 3, b to the exponent of 2, c. All right. So this is what you're going to have on the LCM. All right, we move on to the HCF. That is 3.33, 3.33. We are now asked to find the highest common factor, which is the HCF. So remember the HCF, a term or a number has to be common throughout. That's the first thing. A term or a number has to be common throughout. And when it is common throughout, you must consider the one with the least exponent or the least power. So which one has got the least exponent but being common? Okay, so let's start with 2. 2 is not common. We do not have 2 on 81, so we can't take 2 on HCF. We move on to 3. We have got 3 on 12. We've got 3 on 81. But which one has got this least or the smallest exponent? That is 3. So you're going to take this 3. So our HCF is going to be 3. We move on to the letters. A is common. We've got A here. We've got A here. But which one has got the smallest exponent? That is A. Not A to the exponent of 3, but this A is the one with the smallest exponent. B is also common, but this one is the one with the smallest exponent. C is also common, but which one has got the smallest exponent? These two are the same, so we just take it as it is. So this is going to be our highest common factor, 3A, B, C. All right, so that was our question 3, having a total of 14 marks on everything. All right, so these are the typical questions, guys, that you might be given, and that's how you're supposed to answer these typical questions. All right, on question 4, we are now given 4.1 to solve for x. So what type of an equation that you are solving? This is the first question that you're supposed to ask yourself. What type of an equation? This is a linear equation where we can simply expand our brackets to solve in this case. All right, so let's just expand our brackets here. 2 times 2x, that is going to be 4x. 2 times -1, which is -2. Minus 3x is equal to 4 minus x. All right, so in this case, we can collect like terms, or we can simplify first from the left-hand side, we collect the terms and combine them. This is 4x minus 3x. So 4 minus 3, this is going to be x. So that's x minus 2. Okay, so here we simplified 4 minus 3, we got x, but we still have a minus 2. So this is equal to what we have on the right-hand side, which is 4 minus x. So from there, we can now combine the terms, collect terms. Minus x to the left-hand side is going to be a plus. So that's x plus x, which is equal to, if we transpose the negative 2 to the right-hand side, it is going to be a plus again. That's 4 plus 2. So x plus x simply means 1x plus 1x. So this is 1 plus 1, which is 2. So that's 2x is equal to 4 plus 2, which is 6. Divide by 2 both sides, by 2 both sides. So x is going to give us a 3. All right, so this is what we're given in this case. All right, 4.2, that's another question that you're given, which is having 3 marks, where we're given now to make the subject, Q the subject of the formula. In this case, we're given to make Q the subject. Okay, so let me just rewrite or manipulate. To manipulate is to make the subject. Okay, manipulate the given formula and make Q the subject of the formula. All right, that was a question 4.2. All right, so let me just rewrite my question here so that we can have the solution. So we were given on 4.2 that B is equal to the square root of 3p, that was 3pr over 2 pi q, like this. Okay, so this is what we are given from, and we are asked to make this, to make Q the subject from this. Okay, we are asked to make Q the subject. So what can we do? If you had to check, Q is actually inside the square root. So how can we remove this square root so that we can get rid of the key of the Q that we have? We can square both sides. By squaring both sides, we are removing the square root automatically. So that's B squared is equal to 3p. This is 3p r over 2 pi q. So if you have to check, you've got a fraction, and this is a single term which can be written as over 1 to make it a fraction. So we can remove fractions by cross multiplying. That's here. 1 is going to multiply this side. B is going to multiply 2 pi q. So this is going to be 2 pi q times b squared, which is equal to 1 times this side. It's 1 times 3pr, which is 3pr. So remember, we are supposed to make q the subject of the formula. And what is affecting q right now is the 2, the pi, and the b squared. So what can we do with this? We can simply divide, since we are multiplying. So if we divide by 2 pi b squared, we can divide 2 and 2, pi and pi, b squared and b squared. Thus, we remain with the q. So therefore, our q is going to be equal to 3p r over 2 pi b squared. Okay, so this is what we had in this case, in this question, guys. That's our q as the subject of the formula. In this case, our q as the subject of the formula. Okay, so these are the typical questions that you might be given. So this was actually 3 marks for that, to make you the subject. All right, we move on to question 4.3. Use the answer in question 4.2 and substitute the following values to calculate the value of Q. So we are given P, we are given R, and we are given B. So what you simply do is to substitute these values. Already we have made the Q the subject. All right, so we are going to simply substitute into the formula that we made the Q the subject in this case. All right, so remember our Q here, this is our Q, which is equal to 3p and so forth. So we're simply going to substitute our values into our formula in this case. All right, so this is what you're going to have. So that's 4.3. So our Q is going to be equal to, so we take the values that we are given. Remember that we are given that our P in this case is a -2, our R in this case is a 5, and our B is a 4. So you can simply substitute this into the formula. Q is equal to 3 times P. So this is 3 times P, where P is -2, times R, which is 5, everything over 2 pi B squared. So this is 2 pi times B squared. Our B is 4, which is 4 squared. All right, so this we can simply use our calculator at once to simplify this. So if you plug in your values properly on your calculator, this is going to give us -0.29 8, 4, 1, and so forth. So this is going to be 8, in this case, to 3 decimal places. All right, so this is how we can actually answer these typical questions. So that was our question 4.3. All right, on 4.4, we are given a word problem here. All right, that's a word problem that we got. And we've got the information that we are given. That's 4.4. All right, let's just see what we're given here. We are given that the sum of 3 consecutive even numbers, consecutive, that's following each other in that manner. So we've got even numbers. Remember, even numbers are referring to 2, 4, 6, 8, and so forth. So consecutive, that's following each other in this manner. So we're given that the sum of these even numbers, which are consecutive, is equal to 24. Determine the 3 numbers. Let the first number be x. Okay, so if the first number is x, if you are to check even numbers, they have got a difference of 2. If we check here, 4 minus 2, that is 2. 6 minus 4, that is 2. 8 minus 6, that is 2. So each even number is separated by a 2 from another if they are consecutive even numbers. So if our first term, if we are given that our first term or the first number is x, meaning to say the next number is going to be x plus, just like this. If our first even number is 2, the second even number, since there is a difference of 2, we are simply going to add 2. 2 plus 2, that is a 4. If we've got a 4, we simply add 2. 4 plus 2, that is a 6. So if we are saying our first term is x, it means the second term is going to be x plus 2. We are simply adding 2 because they are even numbers, consecutive. So the third one, we are going to add a 2 again. So if we have got x plus 2 and you add another 2, that's 2 plus 2, which is x plus 4, meaning to say the third term is going to be x plus 4. So that's how we can simply have a sequence of even numbers which are consecutive if you are given the first term. But this is not the idea that we are talking about. The question is, we are supposed to have this because we are given a condition now to determine these 3 numbers. If their sum is 24, meaning to say, if we add these 3 consecutive numbers, we are supposed to get 24. And these are our terms in terms of x, these ones. So if we add x, the first term, plus x plus 2, our second term, plus x plus 4, which is our third term, we must obtain a total of 24, the one that we are given. So like I said, this is your first term, your second term, your third term. So we are told the sum is 24. So we are going to add. All right, so this is the equation that we have formulated. And from this, we are going to solve for x. So let us have our x. So this is same as 1x, 1x, 1x. So if you add, it's 1 plus 1 plus 1, which is 3x. We move on to the numbers. This is 2 plus 4, which is going to give us 6. So 3x plus 6 is equal to 24. We want to solve for x. So 3x is equal to, we transpose 6 to the other side so that it can be a negative. So that's 24 minus 6, which is 18. Divide by 3 since we are multiplying so that we can obtain our x. So x is equal to 3 into 18, or 18 divided by 3, which is 6. So our x is 6. But this is not the question. The question is for us to have or to determine the 3 numbers. Determine the 3 numbers. So the 3 numbers are these ones that we wrote in terms of x. So if we wrote these numbers in terms of x and we said our first term is x, so meaning to say our first number is 6. So therefore the 3 numbers is going to be 6, the first one, okay, followed by our second number or our second term here, it's x plus 2. So that is our x, which is 6. So it's 6 plus 2. Remember x plus 2. So it's 6 plus 2, which is 8. The third term is given as x plus 4. So our x is 6. So 6 plus 4, which is 10. So these are the 3 numbers that we are given, the 3 consecutive even numbers, which gives us a total of 24. So if we add 6 plus 8 plus 10. We must get a total of 24. If not, then it means whatever that we're doing now is wrong. All right, so these are the typical questions that you might be given on word problems. So you have to be very, very careful, guys, on formulating the word problem and so forth. All right, on question 4.5, we are now given a condition that Jacob notices a smoke that notices a smoke coming from a canoe situated on a signal hill. 3.5 seconds later, he hears a bang. So this is what happened. If the speed of sound is 355 meters per second, determine the speed, the distance between Jacob and the canoe. Okay, we are given the time that took the sound to reach to Jacob in this case. So which means in this case, we've got the time of 3.5 seconds and the speed, which is in this case 355 meters per second, and you're asked to calculate the distance. Remember that distance is simply speed times time. So our distance is simply speed times time. So here we are going to multiply the speed 355 times the time 3.5. Take note, this is meters per second. Our time is in seconds. So we are going to simply multiply, and our distance is going to be in meters. All right, so if you multiply 355 divided by 3.5, we are going to obtain 1,242.5, which is in meters. So this is going to be our distance in this case. All right, so that was our question having 3 marks, and the total on question 4 is 16 marks. Okay, so that's how these questions can be like, guys. Okay, let's check what we have on the other part of the question, which is on question number 5. This was a question on graphs, where we are to apply our graphs to answer these typical questions. 5.1, determine the equation of a straight line with a gradient of -3 and the point with the coordinates of -4, 6 on a straight line. All right. So we are asked to determine the equation of a straight line in this case. So to determine the equation of a straight line, we've got so many ways that we can apply. Okay, so I'm just going to apply this space here. So that is question 5.1. So 5.1, we need to determine the equation. We are given the gradient. So our gradient, remember, it's m. So m is equal to -3. And we are given one point which lies on that line, which is -4, 6. How can we determine the equation of a straight line from a point and a gradient? We know that the equation of a straight line is given from y is equal to mx plus c, or we can formulate this from this equation of y minus y1 is equal to m into x minus x1. This can also give us the equation of a straight line. So I'm going to start with this first part here, where we are given y is equal to mx plus c. It simply means that y is equal to m, which is your gradient, which is -3. So that's -3x plus c. So from this equation, what you need is to substitute the point that you are given. In place of y and in place of x, you substitute the point. This is your x and this is your y, so that you can obtain the value of c. So that means here we are going to have our y is 6. So 6 is equal to -3 times x, of which your x is -4. So that's a -4 in this case plus c. So 6 is equal to -3 times -4 from your calculator. That's a +12, which is plus c. So we can transpose the +12 to the other side so that it can be a negative. So that's 6 minus 12 is equal to c. -6 is equal to c. So meaning to say, if c is equal to -6, therefore our equation is supposed to be written as y is equal to, from this part here, that's -3x plus c, which is a -6. So plus and a minus, that's a minus. So this is the equation that we are going to obtain in this case. All right. So like I said, yes, we can actually obtain the same equation that we have from this format that we have. So what does this format actually represent? It represents a gradient and a point, which is the same way as what we had. But this time, we are supposed to have it as y minus y1, which is, this is now our y1, x1, which is 6. M does not change. M is your gradient, and your gradient is -3. So that's -3 here into x minus x1. So our x1 is a -4. So -4, that's a +4. So this is going to be a +4. Okay, expand brackets by -3. Y minus 6 is equal to -3 times x, which is -3x. -3 times 4, that's a -12. So what you can do is to transpose the other part of the equation, which is the 6 to the other part of the equation, so that it can be a +6. So meaning to say y is equal to -3x minus 12 plus 6, which is -6. So this is the equation that we can obtain from another presentation, which is one and the same thing. So you can actually have the equation of a line, not from only a limited part, but you can actually use another part to determine the equation of a straight line. Okay, so that was our first equation on question 5.1 to determine the equation of this line that passes through this point and has got a gradient of -3. Okay, if we check on other part of the question on 5.2, we are asked to draw the graph, draw on a graph paper and on the same system of axes. We meaning to say whatever that you're going to have, it must be on the same graph. So you're supposed to draw xy, which is equal to -2, and y is equal to minus 2x plus 2. Use the domain. The domain, these are the limiting values. We are limited that our x is supposed to be taken from -3 up to +3 to draw the graphs. Okay, so this is what I'm going to do in this case. I'm going to present it on this part. I'm going to write these equations, but do them on this graph here. All right, I had another graph that I have here. So let me see. All right, let's have the table first in this case. Okay, so here, what you're going to do, you simply have a table. So I'm going to use this part of the graph. All right, so let me use this part of the graph. So if you check here, I've got the x-axis and the y-axis. I just decide to use this two boxes representing 1 and so forth, -1, -2, and so forth. So this is my x-axis and the y-axis. All right, so we are going to apply it on this graph. Okay, so let's just have our equations first. So remember that the first equation, okay, this is 5.2. The first equation, it was xy, which is equal to -2. Remember, this is a hyperbola, which we can write in the form of y is equal to a over x. By dividing by x, this part, if you divide by x, it means y is equal to -2 over x. Or you can just even leave it in this form. What matters is this a here, that it is a negative and the shape and so forth. But this does not matter at all because you're going to have a table at the end. So this way is just good if you are to draw your table. So your table is going to be taken from the values that were given. Remember, we were given our values of x from -3 up to +3. So I'm going to have my x and y values. So x is the one that is taken from -3. That is -3, -2, -1, as 0, 1, 2, 3. Okay, so this is how we can separate our values in this case. Okay, so let's see the first value. If our x is at negative, so what you simply have to do is to substitute here. If your x is -3, you substitute here, you get the value for y. So on your calculator, that will be 0.66 and so on. So you can just write this as 0.6 or 0.7 to 1 decimal place just for drawing the graph, okay? When x is -2 divide by, you substitute -2 over -2, you find the value of y, which is a +1. When x is -1, -2 divide by -1, that's a +2. When x is 0, meaning to say we do not have a value, x cannot be equal to 0. So that's an infinity there. That means that's our asymptote. When x is 1, -2 divided by 1, that's -2. When x is 2, it's going to be a -1. This is going to be -0.7 to 1 decimal place. Okay, so these values or these points are the ones that you're going to mark to draw our graph. Okay, so you simply have to mark some with the approximation that you're given. Here, you're simply saying this is a point that you're going to mark to say at -3 and y being 0.7. So you just save the values of x in the negative here. That's a -3. and our y is supposed to be 0.7 a positive. That's 0.7 maybe about, since I used 2 boxes here, like what I did here, I used 2 boxes to represent 1. So it means I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes representing a 1. So meaning to say 0.7 is simply the small boxes, 7 small boxes that I'm going to count. So here there are 5, 6, 7, maybe somewhere here. This is where I'm going to mark my point, where x is -3 and y is 0.7, -3 and 0.7, just 7 boxes going up because of my scale that I choose to use. Okay, so this is how you simply mark your points and so forth. Okay, we move on to the other point, -1 versus -2 versus 1, meaning to x is a -2. Our x here is a -2, y is a +1. Where these two meet, they meet at this point. That's where you mark your point, -2 versus a 1. The same thing we do here on -1 versus 2. So x is -1 this time. If our x is -1, that's here, and y is a +2. This is the part that you're going to have here. So you join these points. These are the only points that you have. So what you need is to join properly. It's just because here, guys, I'm not good at sketching and drawing this, but you're supposed to draw a smooth curve joining these points. All right, so let's just hope I'm going to win. All right, so you join to this point. Okay, this is not smooth as I'm expecting it to be. Okay, so let me just remove this part again. But you're supposed to just have a smoother curve drawn, joining these points and so on. All right, so just something of this nature. Okay, so this is the first part. But remember, we still have another part here because at 0, we do not have anything. This is at infinity at 0. So we move on to 1 versus -2. So this is 1 versus -2. That's somewhere here. 1 on x, -2 on y. So that's somewhere here. We mark our point, 1 versus -2. All right. We do the same here from 2 versus -1. So this is 2 versus -1, 2. And -1 is going to be somewhere here. 2 versus -1, somewhere here. And we move on to 3 versus -0.7. So -0.7, 3 versus -0. We count 7 boxes going down just like the previous part. So these are the points that you're supposed to have on the other side. So you're supposed to join these points just like the previous part. All right. So here we are supposed to join. All right. That's something of this nature. All right, so you're going to join. So you just have to make sure that you draw a proper graph. Okay, so this is the graph of x, y, which is equal to -2. All right, so here we are supposed to have a smooth graph, guys, only that mine is not as smooth as it's supposed to be. All right, but this is how it is supposed to be like. You check the other part. We were also given here also a straight line. There are 2 graphs. Also, the graph of y is equal to -2x plus 3. So this is a straight line graph. Y is equal to -2x plus, that's a straight line graph. So how do we draw a straight line graph? We can use the intercepts, or we can simply use our values. Remember, okay, let's just have our equation. We are told that this one is the line of y is equal to -2x plus 2. So just like the previous part, if I am to create a table, just like the previous part, okay, this is too much ugly. All right, so let's just have it this way. All right, so we're gonna have our x and our y here. So if you're gonna have our x and y, so for a straight line, you just pick any 3 values. Like here, I'm gonna pick -1. I pick 0, and I pick 1. So any three of your choice, or you can use the y-intercept and then the x-intercept. So when x is -1, you substitute into this equation, y is equal to -2 into -1 plus 2, where x is -1. So your y is going to be a 4 on this case. So here y is going to be 4. When x is equal to 0, you do the same thing. Y is equal to -2 times 0 plus 2. Because x is a 0, you're going to obtain a 2. When x is 1, you do the same thing. Y is equal to -2 into 1 plus 2. So y is going to be a 0. So these are the points that you're going to mark just like the previous part. -1 versus 4, 0 versus 2, 1 versus 0. You mark these points, then you can draw your straight line. Okay, so we've got -1 versus 4, that's -1 here versus 4. Okay, 4 is actually on top here. All right, -1 versus 4, -1 versus 4 on top there. You mark your point. That's at -1 versus 4. All right, we move on to the other point. That's here 0 versus 2. So 0 versus 2, that means our x is at the origin, then our y is at 2. That's 0 versus 2. So we've got 0 here versus 2 at this point. So we mark direct on the y value, 0 versus 2. The other point, that's 1 versus 0, meaning to say our x is direct at 1, y is at 0. So there's no movement. That's at direct at 1. So with these 3 points, they're actually enough. So you don't need to have many points if you're dealing with a straight line. These 3 points, they are enough for us to have our straight line. So how do we do now? We are going to join our points. All right. So here you join the 3 points that we marked on our graph. We join from this point up to this one at 2, up to that one at that was 1 versus 0, this one. So these are let me mark them in another part. Okay, this one cannot be clear. Okay, let me just use this one. So we are talking about this point to this point to this point at 1. So these are the points that I need to mark here. So the ruler is supposed to pass through these 3 points. It must pass through these 3 points. If it is not passing through the points, then it means somehow there's some part which is wrong on our symbol. So this can pass. Okay, so this is how our graph is going to be like. So you join the 3 points like this. All right. So we can even extend our line. We just join our 3 points. So here we can even extend a little bit. Okay, we can even extend a little bit. Okay, so this is our line that we got in this case. So this line represents y is equal to minus 2x plus 2. So this is the line of y is equal to minus 2x plus 2. Let's just write here. That's y is equal to minus 2x plus 2. Okay, this is not clear, guys. Let me use another one, this one. So that's y is equal to 2x. That was 2x plus 2, minus 2x plus 2. But if you are to check now, this graph, we just need to extend a little bit from this graph here. Remember, okay, because of this, it's not intersecting. Let's just extend a little bit as it goes up a little bit like this. Okay, so this is what we have. All right, so we have drawn the 2 graphs on the same Cartesian plane or on the same system of axes, the hyperbola and the straight line. So this is how our graphs are supposed to be like, intersecting at this point and also intersecting at this point. So this, because I was using freehand, so it's not that clear, but that is how we are supposed to have our graphs. Okay, so the question was for you to draw the graph, 6 marks for that. Okay, so I just hope, guys, we understand what is happening here. We understand what we are having. All right, so I just hope we understand. But for more questions, we shall have as much as we can. Okay, so the question is done. We move on to 5.3. Determine the gradient. Given this equation, determine the gradient and the y-intercept of the equation. Okay, so remember that we can have the gradient and the y-intercept if we can write our equation in the form of y is equal to mx plus c. That is the y, that is the gradient intercept form. So in this case, we are given minus 2y minus x plus 8, which is equal to 0. So we are supposed to have in this form where m is the gradient and c is the y-intercept. So we can simply transpose all other variables to the other side of the equation, minus x and 8. So minus x to the right-hand side is going to be a positive x. 8 is going to be a negative 8. So we can divide by -2, both sides by -2. This is going to be y is equal to, so this is same as we've got 1 over minus 2. So this is like what we have there. So 1 over minus 2 is simply minus 1 over 2, which is multiplied to x. Then minus 8 divide by minus 2. This is going to give us a plus 4. So this is what we have, guys. From this part, we can see our gradient, which is m. M represents the gradient. So in this case, our gradient, which can be written as m, is -0.5. And the y-intercept, which is this part, the C represent the y-intercept, which is at 4. So that's at x is equal to 0, y is equal to 4. So that's how we can write our y-intercept from there, from our equation. All right, so that was our question 5, having a total of 18 marks. So these are the typical questions, guys, that we are or we might be given. All right, we move on to the other part of the question now, which is on question number 6. So on question number 6, we are given choose a triangle from column B. So you choose from column B that matches, take note here, that matches the congruent triangle in column A. So there's a triangle in column A which is going to be matched with the one that is in in column B in terms of congruence, not similarity, but congruence. Okay, so let's check what we got in this part. We've got these triangles. Okay, let's just try. Okay, this is gonna be okay. So the first part, 6.11, we are given this triangle on column A, triangle NEMO. So this triangle, it is congruent to which triangle? Remember, the congruence is all about being the same. You look for the same triangle like this, NEMO. So let's look for a triangle like this here in column B. So we are supposed to be thinking about this one, which is the last one, because here we are represented the sides. Take note here, the sides, they are presented, all of them. So we take any from any to M to O, from any to M. If you check here, this order here, this 2 to this 3 to this 1. So we are going to follow that order from U to this 1 to this 3 to W to, okay, from U to W here, then back to V. This is the triangle that is actually congruent. So this is going to be at D. All right. So at D, we are given. Also, what was the question here? What are we supposed to? Okay, write only the letter A to D. Okay, so this is D here. So 6.11 is just D. Okay. So that is what we are given, because we are just given to write the letter to say it's just D. Okay, but our triangle, that is the corresponding one. Okay, we move on to 6.12, triangle CBA. CBA, this type of a triangle, where do we see it? We see it on this part here, that is on C. This is what we see on this part here, where we're given X, Y, Z. These two, they're actually the same if we check. So this is for C. So our C here is our answer. Okay, we move on to the right angle concept here. Take note the presentation. We have got a 90-degree, but we've got these two sides, mark this side and this side. So this is what we have here, 90 degrees and these two sides. So this is the B here. So our answer is from B. All right, then this one, we have got the right angle hypotenuse side. The right angle is indicated, I mean, the hypotenuse is indicated. So we are going to take this one with the hypotenuse. So our answer there is going to be A. All right, so this one, that was a direct question on your congruence, guys. I just hope you understand this part. Okay, so that's the first part of question number 6, which is 6.1. All right, we move on to the other part of the question, which is on question 6.2. 6.2, we are given a triangle. Okay, from this given information, calculate the length of MP. This length MP using, you are given, guys, what to use? Pythagoras theorem. All right, remember that the Pythagoras theorem states that the length of the hypotenuse squared, which is C squared, is equal to A squared plus B squared, or H squared, which is the hypotenuse. The hypotenuse is the longer side, which is MP. So it means MP squared is equal to the shorter sides, which you can state from any way, that is going to be mn squared plus pn squared. So we can substitute our values, that is mp squared is equal to the shorter sides, 0.4. So that's 0.4 squared plus 0.3 squared. So mp squared is equal to, if you combine everything, you're going to obtain 0.25. So to find mp, introduce the square root both sides. So from your calculator, the square root of 0.25 is going to give us 0.5. Take note of the units. Okay, in this case, we are not given units, so you just write it as 0.5, or you can write it as 0.5 units, since we are not given to say it's meters or it's centimeters. All right, so that was our question 6.2, marking the last part of our question 6, having a total of 8 marks. We move on to question number 7, where we were given to write down the trigonometric function of sine C cosine of B and so forth and so forth and so forth from this. Okay, so you're given actually take note here, guys. We are given 90 degrees, meaning to say this is a right angle. No matter how your diagram looks like, this is a 90 degree. So remember, from our ratios, let's just write this from our soccer tower, here. So let's start with the sign of C. So the sign of C, the sign means opposite over hypotenuse. So this is opposite over hypotenuse. But according to C, this is our angle C. Which part is the opposite? The opposite is this one that is faces C. This is the opposite. The hypotenuse is 14. So this is going to be opposite 12,35 over the hypotenuse, which is 14. We are done. We are done at this stage. You can leave your answer like this, or you can simplify from your calculator. This is going to be 247 over 280. Okay, so that was it, or you can just leave it like that. Okay, let's check the other part of the question, which is cosine of B. So the cosine of B from our ratio cos is adjacent over the hypotenuse in this case. So if we are relating to B, we are now on this side. This is our B here. What is the adjacent according to B? The adjacent is 12,5, the one that is at 90 degrees with the one that is sitting with 90 degrees in the same line, the 12,35. So this is going to be adjacent, which is equal to 12,35 over the hypotenuse. In this case, our hypotenuse does not change. It's always opposite to 90 degrees. That's your hypotenuse. So as you can see, it's the same answer with sine C, or you can simplify further as 247 over 280, or you can just leave it like that, okay? Then the other part is tan C, tan this angle C. So from the ratio of tan, all right, so let's see here. From the ratio of tan, we've got opposite over adjacent. So this is opposite over adjacent. According to this C, which is 62 degrees, the opposite side, this is the opposite side, over the adjacent, which is this side here. This is the adjacent. So meaning to say here, we are forced to calculate this side because we do not have the adjacent. So where can we have the adjacent from? Remember, this is a right angled triangle where we said from a right angled triangle, the hypotenuse squared is equal to a squared plus b squared. So since we want to calculate CA here, which is the shorter side, we can just substitute our values. Hypotenuse is 14 squared, which is equal to the shorter side. We've got 12,35 squared plus b squared, which represents CA. So you can transpose 14 squared minus 12,35 squared is equal to b squared. So to find b, we can simply introduce the square root. So our b is going to be 6.594 to 3 decimal places, representing CA. So your CA is going to be 6,594, which is the units that you're having. So this is your adjacent. Remember, we are saying tan here is opposite. So the opposite of 62 is 12,35, but over the adjacent now, according to 62, this is our adjacent now, the one that is at 90 degrees, the one that is sitting with the 90 degrees, which is we got 6,594. So this is going to give us the tan of C, which is going to be 1,873. All right, so this is how we can evaluate. So take note, guys. They know that you guys, you just want to see a right angle triangle drawn like this or drawn like a right, as long you are given that it's 90 degrees. Check for any presentation or expect any presentation on your diagram. Don't just expect these two triangles to say, I'm supposed to see my 90-degree triangle like this. No, it can be drawn in any other presentation. As long you are told that this angle is 90, then apply the concept that you know about 90 degrees. Name your sides according to the angle. So the sides are named according to the angle. All right, so this is our question 7. Move on to the question 7.2. In triangle DFE, we do not have this triangle, but we are given that there's a certain triangle which is referred to as DFE, where E is at 90 degrees. So meaning to say there's a triangle like this where there is a 90 degrees on this triangle, and this 90 degrees is at E. So if it is at E, that means we are going to maybe just write D EF. So this is going to be my DE up to F. What I want is E to be 90 degrees. So we are given the length of DE, that is from D to E, that is 43 units, from E to F, which is 72 units like this. Calculate the magnitude of sine F. So we want the magnitude of sine F, sine of this angle. Remember, this part we wrote it before, guys. We say the sine is taken from opposite over hypotenuse, from SOHCAHTOA, opposite over hypotenuse. So the sine of F is opposite over there. We do not have the hypotenuse. We are forced again to calculate the hypotenuse, which is DF. Okay, so let's calculate our hypotenuse. Remember, the hypotenuse squared is equal to A squared plus B squared. So meaning to say hypotenuse, which is DF squared, is equal to A squared. This side's 43 squared plus 72 squared. So to find DF, introduce the square root. We are done. So DF is going to be the square root of 43 squared 43 squared plus 72 squared, which is going to be 83,863, something like that, to 3 decimal places. So this is your DF. So meaning to say here, we can substitute, because we now have the hypotenuse 83,863. So meaning to say, on your formula where we said opposite, according to F, this is our opposite, which is 43, over the hypotenuse, which is 83,863. So you can simplify this as a decimal. That is going to be 0,513, like that, okay, to 3 decimal places, okay? So that's what we had. We move on to the cosine of D, in this case, 7.22. The cosine of angle D, remember cos from our SOHCAHTOA here, cos adjacent over hypotenuse. So it's going to be adjacent over the hypotenuse, of which the adjacent, according to angle D, this is your angle D here. This is our angle D. This becomes the adjacent, the side that is sitting together with 90 degrees. So this becomes our adjacent, which is 43. So we're going to have 43 over the hypotenuse, and our hypotenuse is 83. So these two are the same, actual 83,63 and so forth. So this is going to be 0,513. So these two are actually the same. Okay, so this is how we can attempt these typical questions. That was our question 7.2, working with triangles there in our trigonometry and so forth. Okay, so let's check the other part of the question that you're given and see here. All right, so let me try to push this aside. Okay, so on question number 8, we are given here that there is a cone that is filled with peanuts. The radius of the cone is 6 centimeters and the perpendicular height is 10 centimeters. Calculate the volume of the cone. Whether this it was filled by what, or it was, what is important is we need to calculate the volume of this cone. Okay, how do we calculate the volume of a cone? So this is 8.1 from your formula sheet. The volume of a cone is given as a third base area times height, which is 30 pi r squared h. So we have got the height, we have got the radius, and we've got the perpendicular. So you can calculate our volume. That's a third times pi times radius squared, which is 6 squared, times the perpendicular height, which is our h. So our h is 10. So this is going to give us the volume, which is 120 pi. That's something like 376,991 cubic units or cubic centimeters in this case. So it's very important that you apply the units that you are given in this case. All right, so that was the first part of question 8, 8.12. We are now given to determine the diameter of the cone. All right, so these are just questions just to fill up the 100 marks, because here just diameter, guys, is 2 times radius. Already you've got the radius here. The radius of the cone is 6. So our diameter is going to be 2 times 6, which is 12 centimeters. So take note also of the units. So that was just 1 mark there. On 8.2, we were given a certain shape that has got a square, and we have got a circle inside. So we've got a combination of 2 shapes here, a square and a circle. Then we asked on question 8.21 to calculate the area of the square. So the square is this outer shape that we are given. Remember that the area of a square is simply side squared, or side times side. So that is 28 squared, and 28 squared gives us 784 square centimeters. Okay, so that is our area. And we move on to the circle. 8.22, calculate the area of the circle. So the area of the circle, depending with what you're given and what you want to use. Here, the 28 represents from also this side to side, from this side to this side. So this represents actually the diameter of the circle. This is from this point to this point. So this 28 is also a diameter to the circle. So remember that from our formula, the area of a circle can be given as pi d squared over 4. So this is going to be pi times our diameter, which is 28 squared over 4. So this gives us the area of a circle, which is going to be 615,752 square centimeters. That is to 3 decimal places. Okay, but we can just save to 2 decimal places if we want. Okay, 8.23, calculate the area of the shaded portions or sectionalized section that we have. If you check, there is this part that is shaded, that is the shaded part here. So we can simply, if we remove this circle here from the square, if we remove this circle, that is where we remain with the shaded part. So it simply means the area of the shaded part is the difference from the area of a square. We are going to simply subtract the area of a square minus the area of a circle. So this is going to be 784 minus 615,752. So this gives us the area of that part which was shaded in this case, which is going to be 168 something, 168,248 square centimeters. So this is for the shaded portions that we had in this case. Okay, so that was just 2 marks for that. On question 8.3, we are now given to calculate 12.75% of 1,596.53 rand. Show the working. So which working can we show here? Okay, so 12.5 to remove a percentage. Remember, it's over 100. So this is going to be 12. We can write it this way: 12.75 over 100 to remove the percentage. Then we are said off. That is off is to multiply. So that's times 1596.53. Okay, so this is the same as over 1. So you simply use your calculator to multiply. So this is going to give us a total of 203,567 and so on. So you can have this as 557, which is going to be 56 to 2 decimal places. If you are referring to money, you round off to 2 decimal places. Okay, so that was 12.75% of this. And on 8.4, we are given that a lecturer bought a car for 205,000 and later sold it for 136,000. What was the loss in value? So actually, this is a loss. We got it at 205. We sell it at 136. So how can we calculate the loss? We simply subtract these two. The loss is going to be the difference. Okay, so that is 205,000 minus 136,000. All right, which is going to be 69,000 if we subtract properly. So we have got a loss of 69,000 rand. Okay, we are supposed to say the selling price minus the buying price. But if it is a loss, we are now saying the buying price minus a selling price, which is not even normal in our calculations. All right, so 8.42 express the loss as a percentage. So remember, the car was originally bought at 205,000. So meaning to say the percentage is going to be the loss that was incurred, which is the loss of 69,000 over the total that was there before. And our total is 205,000 times 100%. We have a percentage in the loss. Okay, so a percentage in the loss is a loss of a total times what we had before. So this is going to give us 33,659% to 3 decimal places and so forth. So that is how we can calculate this, or you can even approximate this to, you can actually approximate this to the nearest whole number, which is fine. Okay, so that was question 8, which marks 14 marks on everything and a total of 100 marks in this question paper. So that was our APU 2023 question paper from Maison African Motives. Till we meet again.